aren't paying attention to me, and now I got this that's not paying attention to me. It's ridiculous. Being a teacher, it's rough. Okay, so Bailey's got 0.9. And just some advice, don't forget parentheses, right? You need parentheses, 0.9 minus 1 parentheses divided by parentheses. Okay, so do I have a volunteer for 0.99? Yes, what's your name?
Allison.
Good to see you, Allison. 0.99? Okay, how about 1.01? What's your name?
Josh.
Josh, thank you, 1.01, and then I need somebody for 1.1. All right, Tommy. All right, so, and everybody else, just try one of them. See if you can match what they get. If you forgot your graphing calculator today, don't worry, it's just minus 1,000. See, I told you I was sarcastic all the time. So Bailey, you got 0.9, what do you got?
0.526.
All right, 0.526, awesome. What do you got for 0.99?
0.503.
0.503. All right. 1.01. Not
0.498.
okay. Cool, Josh. Tommy, you got the 1.1 yet?
Yeah, 0.476.
Awesome. Okay, so the x arrow 1 means pick numbers that are getting close to 1. So that was our first step. Then this is our function. So we plug those 4 numbers into that function. Okay, so we've done this part of it, right? Pick numbers close to 1. We've done this part of it. Now we have to do the LIM part of it. And the LIM part of it means look at the numbers you got and see what they are getting close to. So LIM is kind of a complicated set of instructions. It says pick numbers close to 1, put them in here, and then look and see what they are getting close to. So our job is to look at these numbers here and try and see what they're getting close to. And it's kind of a guess when we're doing a table like this. So what do you think these are getting close to? 0.5 is correct. So the answer is 0.5. So the limit as x approaches 1 of this function is 0.5. It doesn't mean that the numbers are 0.5, it just means that the numbers are getting close to 0.5. Okay, so that was part A. And now we're going to do part B. And the question there is f parentheses 1. So what does f parentheses 1 mean? Yeah, Zach? It means put 1 in, right? Over here, it specifically said don't plug 1 in. It said just plug numbers that are close to 1 in. But now this says plug 1 in and see what you get. So when you plug 1 in, 1 minus 1 is 0. And 1 squared is 1. 1 minus 1 is 0. 0 divided by 0. That's bad news. It doesn't exist, right? So f of 1 does not exist. So the limit as x approaches 1 is a half, but when x is actually 1, the answer doesn't exist. So I'm putting these problems next to each other to emphasize that they are different questions. This question has an answer. It's 0.5. This question doesn't have an answer. Okay, let's try another. How about limit as x approaches 3 of x plus 1 over x squared minus 9. Okay, so what does this x arrow 3 mean? Yes, Stephen.
Find numbers that are close to 3.
Pick some numbers that are close to 3. Oh, yes, and I like what he's about to say. Say that. That aren't specifically 3. Just numbers that are close to 3. Okay, so I'm going to make a table. Sorry, this is part A again. So I'm going to make a table, pick numbers close to 3. And I've been doing this for too long, and so I get into a rut, and I always pick the same ones, 2.9, 2.99. There's no reason it has to be those, but, you know, after 7 years of calculus, you get into a rut sometimes. Okay, so volunteer for 2.9. Yes, Steven. Steven's got 2.9. Volunteer for 2.99. All right, Bailey. 3.01. Yes, what's your name? Annie, you got 3.01, and you have 3.1. And what's your name? Kylie. All right, I'll learn it eventually. Don't forget parentheses. So I forget who 2.9 was. Steven, you got it?
Negative 6.61.
Negative 6.61. All right. 2.99 was Bailey. All right. 3.01 was, yes. And Kylie, what'd you get for 3.1? That's right. You were doubting yourself. It's good to be skeptical, but you got it. Okay, so the reason she's being skeptical is she's thinking, oh, I can't really tell what these are getting close to. And she's right. We can't tell what these are getting close to. What do you think would happen if we put in 3.001? Yes. 666. Just really bad news, right? And 2.999 would be negative 666. So what actually happens with this function is it's going to keep getting larger and larger. And eventually it's going to be huge, 6,666. And 66,666. It's just going to keep growing and growing and growing as you get closer and closer and closer. And notice that from the numbers that are smaller than 3, it's a negative number. And from the numbers that are bigger than 3, it's big positive numbers. Okay, so we need to find a way to write that down. Okay, so we're going to say that the limit as x approaches 3, we're going to put a little minus sign after the 3. And what that means is the numbers that are smaller than 3. So the 2.9 and the 2.99. So when we pick numbers at 2.9 and 2.99, what happens is it gets really, really big and negative. So really, really big and negative. And then from the other end, when we pick numbers that are bigger than 3, it got really, really big and positive. And by the way, this doesn't exist. Infinity is just a concept. So you could also say that the answer is does not exist. Same thing here. This is negative infinity, which is a concept. It's not an answer. So you could say that the answer is does not exist. Certainly, this answer does not exist. Because these are not the same, right? Okay, I forget. Have you seen this notation in the videos or no? Okay, so it's not brand new. Is everybody okay? Are you sure? So over here, it was getting close to something, It was getting close to 0.5, so that was our answer, because the limit says, what is it getting close to? But here, it wasn't getting close to anything. So that's why our answer did not exist. And then we could specify in what way it didn't exist here. Here it's getting really, really big and positive. Not close to anything, but really, really big and positive. And here it's getting really, really big and negative. All right. That's day one. See you tomorrow. Or no, I'm not going to see you tomorrow. School's starting on Friday. This is crazy. I'll see you Monday.